You just blinked. That blink lasted about a tenth of a second. You didn't think about it, you didn't plan it, it simply happened, and your day kept moving. Now picture something happening in a slice of time so much smaller than that blink that physicists had to invent entirely new units just to measure it. In that sliver, before a single thought could even form in your head, the universe was born, the laws of physics were decided, and the raw material for every atom in your body was forged. All of it in under 1 second. Have you ever actually wondered what happened in that first second? Because the real story is far stranger than the one you were taught in school. You were probably told the universe began with a big bang, some kind of explosion, fire and smoke rushing outward into empty space. That image feels familiar. It's also wrong. There was no explosion happening inside anything, and there was no empty space waiting outside for it to expand into. Space itself was being created, stretched, and folded into existence, faster than light could ever travel, happening everywhere at once, because in that moment, everywhere was the same single point. Why would any of this matter to you, scrolling through your phone on an ordinary morning? It matters because what happened in that first second decided whether atoms could ever form. It decided whether stars could ignite, whether a planet could cool into oceans and continents, whether anything resembling you could ever stand in a kitchen complaining about a slow coffee maker. Here's how it played out. In the very first fraction of that second, a span of time so small it's measured in units called Planck time, roughly a decimal point followed by 43 zeros, the universe was smaller than an atom, hotter than anything that has existed since, and denser than your mind can really hold on to. The four fundamental forces of nature, gravity, electromagnetism, and the two nuclear forces weren't separate yet. They were fused into a single force, acting as one. Can you imagine every force shaping reality compressed into a point smaller than a proton? At that scale, the universe was so small that the rules of gravity and the rules of quantum mechanics, two of science's most successful theories, completely break down and refuse to agree with each other. It's the single earliest moment any equation can currently describe, and beyond it, physics simply runs out of answers. In 1980, physicist Alan Guth proposed an idea that would change how scientists understood that first second entirely. He called it cosmic inflation. According to Guth's theory, the universe didn't just expand, it exploded outward at a rate that breaks every intuition you have about speed. In a fraction of a second, space ballooned by a factor of roughly 10 followed by 26 zeros. Picture a single grain of sand swelling until it stretched wider than an entire galaxy, all before an electron could complete a single vibration. Guth's idea solved a problem that had stumped cosmologists for decades. Why does the universe appear to be nearly the same temperature in every direction you look, no matter where you point a telescope? Inflation smoothed everything out before gravity or light had any chance to make it lumpy or uneven. But inflation didn't smooth everything perfectly. Tiny quantum fluctuations, randomness on a scale smaller than anything you could picture, got frozen into the fabric of space and stretched out to cosmic size along with everything else. Those frozen ripples would eventually become the seeds for every galaxy cluster, and every dark, empty void you can spot in a photograph of the night sky. You're still inside the first second, and you've already witnessed more reshaping of reality than the next 10 billion years will produce. As inflation slowed, the universe cooled just enough for the unified forces to start splitting apart. Gravity peeled away first. Then the strong nuclear force, the one that glues atomic nuclei together, broke off from electromagnetism and the weak force. Energy that had been locked inside that unified field spilled outward, creating an almost unimaginably hot soup of particles, quarks, electrons, and their stranger cousins, swimming through something physicists call a quark-gluon plasma. For every billion particles of matter created in that soup, there was nearly, but not quite, a billion particles of antimatter to cancel it out. That tiny imbalance, one extra particle of matter for every billion pairs, is the only reason anything exists today instead of pure empty light. Nobody knows for certain why that imbalance favored matter over antimatter, and explaining it remains one of the biggest open questions in physics today. Does that sound like science fiction? It isn't. Scientists at CERN's Large Hadron Collider have actually recreated tiny patches of that exact plasma by smashing heavy atomic nuclei together at nearly the speed of light. For a fraction of a second, inside a tunnel running beneath the border of France and Switzerland, they generate conditions that haven't existed naturally since the universe itself was younger than a second old. It's the closest thing humanity has built to a time machine. What would it feel like to stand near a machine recreating the first instant of existence? That same first second also planted one of science's strangest unsolved mysteries. Whatever filled the universe in that moment didn't just make the matter you're made of, it also seems to have made something else, something invisible, that physicists call dark matter. It doesn't shine, it doesn't reflect light, and nobody has directly detected a single particle of it. Yet its gravity is the only explanation that makes galaxies spin the way they do. Entire detectors, buried more than a mile underground to block out cosmic noise, sit quietly right now, waiting for a single dark matter particle to leave a trace. Whatever that trace turns out to be, it was written into existence in that same first second as everything else. Back in that first second, the quarks began locking together into protons and neutrons. The process took mere microseconds. By the time the clock hit 1 full second, the universe had already assembled the raw ingredients for every atom that would ever exist: hydrogen, helium, and the early seeds of carbon, oxygen, and iron that would later form stars, planets, and eventually the calcium sitting in your bones right now. None of it had starlight yet. None of it had anything you could call visible. Can something be foundational to all of existence and still be completely invisible? The universe at 1 second old was an opaque, blisteringly hot fog, too dense for light to travel freely through. It would take nearly 380,000 years before that fog finally cleared enough for the first photons to break free and travel in straight lines. Strange enough, there's a record of that moment, not the 1 second mark itself, but the instant light first escaped. In 1965, two researchers, Arno Penzias and Robert Wilson, were testing a radio antenna in New Jersey when they picked up a strange, constant hiss they couldn't explain. They cleaned out pigeon droppings. They checked every wire twice. The noise wouldn't go away. Could a hiss in an antenna really be a leftover echo from the birth of everything? It could, and it was. What Penzias and Wilson had stumbled onto was the afterglow of that early universe, the cosmic microwave background, the faint, cooled radiation left over from when light first escaped the fog created in that first second. Their discovery earned a Nobel Prize, and decades later, satellite missions mapped tiny temperature ripples across that same afterglow, ripples that traced directly back to quantum fluctuations stretched out by inflation in that very first second. Could the patterns of galaxies scattered across tonight's sky have been sketched out before the universe was even a second old? It's still out there right now. It's leaking through your television static if you tune to an unused channel. You'd be catching photons that have been traveling since almost the very beginning of everything. Here's the part that should really sit with you. Nearly every fundamental rule governing matter, energy, and the structure of reality was decided in that first second. Not over millions of years. Not gradually, the way evolution slowly reshapes a species over countless generations. In 1 second, the universe essentially wrote its own rule book, then spent the next 13.8 billion years simply following it. Some physicists, including Andre Lind, who helped refine inflation theory, have even argued that the conditions of that first second may have triggered countless other universes branching off from your own, each with its own rule book, each frozen the instant its own first second ended. Doesn't that change how instant and permanent sound to you? Stars didn't invent gravity. Your body didn't invent chemistry. Every law your phone, your car, and your heart depend on was already locked in before that first second ended. So what does any of this have to do with you, standing in your kitchen, scrolling your phone, waiting on a slow pot of coffee? Maybe this. You spend most of your life assuming the big decisions take time. Careers, relationships, the person you become, you assume they form slowly, shaped gradually by thousands of small choices stacked over years. But sometimes the truth looks more like the universe's truth. Your amygdala can flag danger and flood your body with stress hormones nearly a third of a second before your conscious mind even registers what scared you. A first impression of a stranger's face can form in under a tenth of a second, faster than you could ever talk yourself out of it, shaping how warm or trustworthy you assume they are before you've exchanged a single word. A habit can wire itself into your basal ganglia after only a handful of repetitions, long before you'd ever call it a habit at all. The conditions for so much of what follows, your instincts, your fears, even how your brain reacts under pressure, get set far faster than you realize, locked in by moments you never consciously remember, decided before you ever had a say. What if the parts of you that feel most fixed were actually decided in seconds, not years? The universe didn't need billions of years to decide what it would become. It needed 1 second. You just blinked again. And somewhere inside that blink, faster than you could ever notice, your brain quietly rewrote a memory, adjusted a hormone, or fired a thought you'll never consciously register, deciding a small piece of who you become next. Just like the universe once did, in less time than it took you to read this sentence.